Chapter 4, Section 10, Missing Data Imputation, Part 4, Data Leakage Python Tutorial. Let's recap the procedure for missing value imputation in supervised learning. First, split the data into training data and test data. Next, impute the missing values for only the training data. For example, when performing mean imputation, the missing values are imputed using the mean value, calculated using the training data only. Next, impute the missing values for the test data. We must impute missing values for test data using the information from the training data. Now, implement the above procedure in Python. In this example, we will perform simple imputation, but KNN imputation can also be performed with almost the same code. When using KNN imputation, simply use KNN imputer instead of simple imputer, and the rest of the code will be the same. First, import the pandas and NumPy. Next, import train test split from scikit-learn's model selection. Use this method to split the data into training data and test data. Also, import simple imputer. Let's create the same datasets as the previous section. Let's check where the missing values are. Motivation has missing data in data point S3. Stress has missing data in S3. Satisfaction has missing data in S2, S8, and S9. Next, use the train test split function to split the training data and test data. This function randomly selects data points from the data frame and splits the data frame using a pseudo-random number generator. The first argument is the data frame to be split. In this case, we will split the data frame named df. We can also set test size, which is the proportion of the data that will be used as test data. In this case, we set it to 0.2, so 20% of the data is used as the test set, and the remaining 80% is used as the training set. Another argument, random state, is used to specify the random number seed. Train test split randomly splits the data, and the random state is used to determine the starting point for the random number sequence of the pseudo-random number generator used at that time. By setting the values of random state, we can fix which data points are selected for the training data and test data, respectively. By doing so, we can compare different prediction models using the same data under the same conditions. There are no strict rules for the value to be set for random state, but conventionally, we usually use 42, 0, 7, or 123. Next, initialize simple imputer. Since we perform mean imputation, set the strategy to mean. Be careful not to forget the quotation marks. Now let's impute the missing data. For training data, apply fit_transform method. It means that we make the imputer learn the training data, and then transform the test data using the information from the training data. In other words, the fit calculates the average value of the training data, and then the transform uses the average value for the imputing the missing data. Next, let's impute the missing values in the test data. Here, we must use transform instead of fit transform. In other words, the imputer should not fit the test data. That is, the imputer should only transform the test data without learning information from the test data. It means the imputer uses the training data's average to impute the missing values in the test data. Now we have completed the missing data imputation. Let's show the imputed training data and test data. We can see that the missing data has been imputed and that all cells now contain data. If we look at the cells where the satisfaction column had missing values, we can see that the same values have been assigned to both the training data and test data. This is because both sets of data have been imputed with the average value of the training data. In this way, we have completed the missing data imputation without data leakage. In the above procedure, we impute missing values in the test data using the average of the training data. Why is it okay to impute missing values in the test data using the average of the training data? The reason is that using the average of the training data for the test data is a method that aligns with realistic operations in that it processes future data using past information. For example, let's consider the case of applying prediction model to employee data next year. If there are missing values in the motivation scores of employees next year, it is reasonable to use the average of the data from the previous year, that is, this year, to impute the missing values. This is a general estimation method which assumes that the situation from the previous year will continue this year. Data leakage refers to the problem in which the information in a test data is used in the training phase, leading to an overestimation of the model's performance. The problem with imputing missing data before splitting training and test data is that, since test data should be treated as virtual future data, it is impossible to use that information in the model training phase. Therefore, we can prevent data leakage by imputing missing values after the data splitting. Thank you for watching. Please thumbs up and subscribe to my channel.